What if there was a mathematical equation that could help us solve climate change? Well, it turns out there is one, and it's something everyone should know. It's called the Kaya identity. The Kaya identity was first presented in 1997 by the Japanese energy economist Yoichi Kaya. It's a way of splitting carbon emissions into their four major driving forces. But before I explain this in more detail, I need to explain what an identity is. An identity is a mathematical equation represented by an equal sign with 3 bars, and it means can be represented as. So you could say 35 can be represented by 5 times 7, or 35 can be represented by 17.5 times 2. Now you're probably saying, well, big deal, Chris, how's that useful? And of itself, that is not too useful. But look what happens when we add units to the terms in the equation. Someone drinking 35 units of alcohol a week might be drinking 5 units a day, 7 days per week. Or they might be drinking 17.5 units twice a week. The first conjures up an image of stressed parents having half a bottle of wine after putting the kids to bed every day. The second implies heavy binging, such as you would see in a British town centre on a Friday and Saturday night. So putting units on the terms of an identity starts to tell us something about the nature of the problem. And that was the insight that Professor Kaya applied to carbon emissions. The Kaya identity breaks down carbon emissions into 4 terms. The first is the energy services per person. Energy services are all the things that we use energy for: mobility, warmth, lighting, communications, and so on. If you want more detail on energy services, check out this link to an earlier video. The energy services per person is essentially a measure of our standard of living. The second term is the energy needed to provide those services, called the energy intensity. This term is all about energy efficiency. The more efficient a device is, the less energy is required to provide the needed service. This is then multiplied by the amount of carbon in the fuel required to deliver that energy, which is called the carbon intensity. Coal produces the most carbon dioxide to deliver a unit of energy, followed by oil and then gas. The carbon intensity of electricity is very variable worldwide, depending on the mix of generation in that country. But renewable electricity, being a zero carbon generation source, is very helpful to reduce the impact of this term. Lastly, we multiply this by the population. It goes without saying that the more people there are, the greater the impact on CO2 emissions. The beautifully simple implication of the Kaya identity is that there's 4 ways, and 4 ways only, of reducing CO2 emissions from energy. We can either do less stuff, use energy more efficiently, use lower carbon fuels, or reduce the population. There's no prescriptive way of saying which of these levers is best to pull, but doing less of one means that you need to do more of the other 3. It's a bit like squeezing a party balloon. So let's take a look at which of these 4 factors are actually driving CO2 emissions. Before I do, I should introduce you to another formulation of the Kaya identity. As we noticed in the last video, governments tend not to use energy services to measure standard of living, preferring to use the gross domestic product, or GDP. So the Kaya identity can be written like this instead, and indeed this is how the Kaya identity was first described. Since 1970, the world population has increased by 120%, whilst GDP per capita has rocketed 150% as living standards have got better. At this point, we should remind ourselves that whether you think this rise in living standards is a good thing or not depends on where you are in the world. It has already lifted billions of people out of poverty, and we're likely to need to do the same again in the developing world over the coming decades. It is only in the global north and among richer sectors of society where we might consider whether a reduction in energy services is required. On the flip side, energy efficiency has improved with better technology and regulation, reducing the energy intensity by 40%. And fuels have got slightly cleaner, particularly with the rise of renewable energy, and carbon intensity has dropped by about 15%. But when we put all this together, these smaller improvements in technology aren't keeping pace with the combined effects of population growth and rising standards of living. So CO2 emissions worldwide have risen by 150% since 1970. Now that we understand the Kaya identity, let's see what governments are actually doing to reduce carbon dioxide emissions. Let's zoom in on each term and see which levers they are pulling. Policies to reduce population are very tricky, and most countries shy away from it. Population policies have overtones of genocide and eugenics, and there's a history of misguided policies, such as the one-child program in China and sterilisation in India. What we can do, however, is to provide sexual education and access to contraception. And women's rights are really important here too. Raising the legal marriage age, improving female education and employment opportunities lowers the birth rates. Governments also don't look at policies that reduce standards of living as measured by GDP, as this would go down terribly with the electorate. It's also rare for governments to try to reduce energy services directly, saying, for example, we should reduce the things that we do, such as by driving less. This would be seen as big government trying to tell us how to live our lives, and would immediately become a new front line in the culture wars. A rare exception here are the French, who do offer their citizens some guidance on how to live lower carbon lifestyles. A recent report advised on how regularly to change their clothes. Good for the environment, less so for stereotypes of French hygiene. Because of the difficulties in addressing population and living standards, it means that the major focus of governments is on energy efficiency and renewable and nuclear power. Note that the focus of reducing CO2 emissions is not on the two root causes, which are population growth and lifestyles. Instead, they're looking at technology to counteract this, a bit like using medicine to address the symptoms, but not the cause. How would an economist look at the Kaya identity? They'd be interested in which of the four levers reduce emissions at the lowest cost. Reducing energy services, the flight not taken, the miles not driven, the laundry load not done, or the light bulb turned off, is completely free. In fact, it will save you money. The population policies of sexual education and advancements of women's rights are also pretty cheap. But energy efficiency policies become moderately expensive. Consider, for example, the cost of adding extra insulation to every single home in the country, or for everyone to switch to a more efficient electric vehicle. But of the four levers, it's building new zero carbon generation that is the most expensive option. The number of wind turbines and solar panels we will need will cost trillions of pounds, and nuclear power stations are some of the most expensive objects on Earth. What about net zero? Ultimately, to solve climate change, we need to get total carbon emissions to zero. And that implies that one of the four terms in the Kaya identity also needs to reach zero. So which ones can actually do this? Well, if population went to zero, the human race would be extinct, which would kind of defeat the point. Similarly, if we reduced our energy services to zero, we'd be back living in a cave. It's neither practical or desirable. Looking at energy efficiency, energy cannot be converted from one form into another with 100% efficiency. It would break the fundamental laws of physics. So the only term that can truly get to zero is the carbon intensity of fuels used, by the complete phase out of fossil fuels and replacing them with renewable sources of power. This is the reason that renewable energy gets so much attention. It may be the most expensive one, but ultimately it's the only one that gets us to where we need to be. The role of the other three terms, which are cheaper, is to provide a helping hand, so we need as little of the expensive renewable energy as possible. In this last section, I'd like to look at who is involved and responsible for each of these terms. Energy services, as we've noted, are driven by the lifestyle choices of individuals, but also by decision-making in business, industry, and other institutions. Energy efficiency is primarily the responsibility of manufacturers to make better products. But people also have an important role here when they choose which product to buy at the point of sale. And governments can also help in terms of setting standards and regulations to make sure the products are up to scratch in the first place. Renewable energy, on the other hand, is being built mainly by utilities and private developers. On the whole, this is the role of big business, although there are some smaller niches, notably individuals who have purchased solar panels and renewable energy projects owned and operated by the local community. Population is a different matter, being addressed through education, healthcare, and tax policy. To sum up, the Kaya identity shows us the 4 levers we can pull to address climate change. Each of the 4 measures is different in terms of their potential for emissions reductions, their costs, their political feasibility, and who is involved. So if you were in charge, which route would you follow? How would you balance the 4 different terms of the Kaya identity? Let us know in the comments section what you think, and if you haven't already done so, do subscribe to get more Energy 101.